Welcome back to NexMEP, your guide to MEP engineering excellence. In today's video, we're going to cover one of the most important topics in electrical engineering, types of circuit breakers. Whether you're a student, a site engineer, or someone just getting into MEP design, this video is going to give you a clear, practical understanding of how circuit breakers work and which type to use where. So let's get started. Before we dive in, let me quickly walk you through what we'll be covering today. First, we'll look at the main functions and advantages of a circuit breaker, understanding why it exists and what makes it better than a fuse. Then we'll move on to the three types of protection a circuit breaker provides: overload, short circuit, and leakage. After that, we'll go through the actual types of circuit breakers, MCB, MCCB, RCCB, and RCBO, in detail, where we'll compare each one side by side to understand exactly how they differ in terms of protection, current capacity, and the right application for each. And finally, we'll wrap up with a quick summary so everything sticks. Let's begin. So what does a circuit breaker actually do? Its first job is to protect your cables and wiring. When a fault occurs, wires can overheat, and without protection, that leads to insulation damage or even fire. The circuit breaker steps in and disconnects the supply before that happens. Second, it protects your electrical equipment, motors, appliances, machines, from damage caused by excessive current. Third, it helps prevent electrical fires by cutting power the moment it detects abnormal current. It also improves overall safety for people, protecting them from electrical hazards. And importantly, it can isolate just the faulty circuit, so the rest of your system keeps running normally. Now let's talk about the advantages. Unlike a fuse, a circuit breaker is reusable. Once the fault is cleared, you just reset it. It operates faster than a fuse, it's safer, and it makes fault identification much easier. In short, it's smarter, safer, and more reliable. Now, a circuit breaker doesn't just do one thing, it provides three different types of protection, depending on the type of fault. The first is overload protection. This kicks in when the current flowing through a circuit exceeds its rated value for a prolonged period. A simple example: plugging too many high-power appliances into a single socket. The circuit can't handle it, and the breaker trips. The second is short circuit protection. This is for sudden, violent faults, like when a live wire directly touches the neutral, causing a massive spike in current. A common cause is damaged wire insulation. The breaker reacts almost instantly. The third type, and this one is critical for human safety, is leakage protection. This is found in RCCB and RCBO devices. It detects when current is leaking to earth, which could be flowing through a person's body, and it cuts the power before serious injury occurs. The first and most commonly used type is the MCB, miniature circuit breaker. As the name suggests, it's a compact device designed for low-current applications. You'll find it in homes, small offices, and lighting circuits. An MCB protects against two things: overloads and short circuits. When a fault occurs, the MCB's trip unit detects the abnormal current, opens the contacts rapidly, and an arc forms between them. This arc is then directed into the arc chute where it gets stretched, cooled, and split, safely extinguishing it and interrupting the fault current. Key thing to remember: MCBs are rated up to 100 amps. They don't protect against earth leakage or electric shock, that's the job of RCCB. But for basic circuit protection in homes and small installations, the MCB is your go-to device. Next up is the MCCB, molded case circuit breaker. Think of this as the heavy-duty version of the MCB. While an MCB handles up to 100 amps, an MCCB can handle up to 2,500 amps, making it ideal for industrial and commercial applications. You'll find MCCBs in factories, industrial panels, and large buildings. What makes MCCBs special is that they have adjustable trip settings, meaning you can tune the protection thresholds based on the specific load requirement. This makes them extremely flexible for industrial use. Like the MCCB works by detecting an overload or short circuit, tripping the mechanism, and extinguishing the arc in the arc chute. But due to the higher current levels involved, the internal design is much more robust. The spring mechanism releases energy quickly to open the contacts and handle the arc safely. Now we come to the RCCB, Residual Current Circuit Breaker, and this one is all about human safety. Here's the core concept. In a healthy circuit, the current flowing through the live wire and the current returning through the neutral wire should be equal. If they're not, if there's a difference, it means current is leaking somewhere. That somewhere could be Earth, or worse, a human body. The RCCB continuously monitors this difference using a current transformer. The moment it detects an imbalance, even as small as 30 milliamps, it trips instantly, disconnecting both live and neutral. This happens fast enough to prevent fatal electric shock. Important note, an RCCB does not protect against overloads or short circuits. That's not its job. It only detects leakage current. So in any installation, you'll typically use an RCCB alongside an MCB, not instead of one. Common ratings are 30 mA, 100 mA, and 300 mA. For areas like bathrooms and wet zones, 30 mA is the standard. And now the most complete protection device, the RCBO. Think of it as an MCB and an RCCB combined into a single unit. RCBO stands for Residual Current Breaker with Overcurrent Protection. It protects against all three fault types we discussed: overload, short circuit, and leakage current. One device. Total protection. Here's how it works internally. The thermal element, a bimetal strip, detects slow overcurrents and bends to trip the device. The electromagnetic coil handles instantaneous short circuit faults. And the RCCB part uses a current transformer to monitor imbalance between the live and neutral, tripping the moment leakage is detected. RCBOs are increasingly the standard in modern distribution boards because they save space, reduce wiring complexity, and offer complete protection for each individual circuit. If you're designing a new DB panel today, RCBOs are often the smartest choice. Now let's bring it all together with a comparison. Looking at the table, the MCB gives you overload and short circuit protection, perfect for homes, lights, and sockets. Simple, reliable, basic. The MCCB adds high current capacity and adjustable trip settings. That's for industries, motors, and large panels. Heavy-duty protection. The RCCB only provides leakage protection. It doesn't handle overloads at all. But for wet areas and human safety, nothing beats it. And the RCBO ticks every box: overload, short circuit, and leakage. No adjustable trip setting, but it gives you all-in-one protection in a single device, ideal for modern DB panels. So when you're selecting a breaker on site or during design, always ask, what am I protecting: equipment, cables, or people? That answer will tell you which device to use. Let's close with a quick and easy summary to lock this in. MCB protects circuits from overload and short circuit. Your everyday home breaker. MCCB protects heavy industrial loads with high current capacity and adjustable settings. RCCB protects humans from electric shock by detecting leakage current. RCBO, the complete package, protects both people and equipment. That's it for part 1 of types of circuit breakers. In part 2, we'll go deeper into more advanced types, so make sure you're subscribed and have the bell notification on so you don't miss it. Please give it a thumbs up and share it with your friends and colleagues in the electrical or MEP field. It genuinely helps more engineers discover this channel and learn these concepts for free. And finally, if you have a friend, a colleague, or a student who is learning electrical engineering, share this video with them right now. One share from you could change how they understand protection systems forever. Subscribe to NexMEP for a new video every week covering MEP concepts, site practicals, drawings, and design tips. See you in the next video. Types of Circuit Breakers Part 2, everything you need to know on site. Don't miss it. Keep learning, keep building, see you there.